Welcome back. Come to the next session. We studied about a 6-unit component diagram. Now we have to see the deployment. After that, deployment diagram is there. Okay. In the 6th unit, we are having component diagram, deployment diagram representation, and the case study of all the models which we studied with the help of one library management system we have to draw. Right? Now, see the deployment. What is a deployment? What is a deployment? The components you develop or reuse a part of your software. The component which you have to reuse the develop a particular software, it is a system must be deployed on some set of hardware in the order to execute. Node represents the hardware on which these components are deployed and execute. In deployment view, every components you develop or you reuse, those will be saving in one particular area. That area is called node represents. Node. What is that? Node. For deployment diagram, the major part of the deployment diagram is the nodes. Node represents the hardware on which these components are deployed and execute. Node represents the hardware these components are deployed and execute. A node is a physical element. What is a node? Node is a physical element that exists at runtime. Where it exists, the node? Node will be exists at the runtime. Node will be exists at the runtime. Node is a physical element. Node is a physical element that exists at runtime and represents a computational resources. What the node can have node can represent the computational resources. That is a node. In deployment diagram, we most probably observe the nodes, right? This is the node symbol. How do we write the node? Node is this symbol. This is the symbol for the node representation. How it write? This is like. This is the node symbol. Node. For this node, you may write the simple name of the node is kiosk 7 portion. Simple name of the node. Extended name also you may use with the help of scope resolution operator as we used in the component diagram. How do we use component diagram representing extents? You may also use to extend the path name. You may also give to the node. Sales node having some deploys pos.execute file and context.execute file, which executable part of a diagram is simply called as a node. In the node we are having simple names and the path names we observe. In between the curly braces also you may represent remote administration only, that the tagged values are also give here in the node representation. That nodes, terms and concepts of the nodes, components, nodes and components, deployments. Components are things that participate in the execution of a system, components, and nodes are the things that execute components. Simple. What are components? Are the things that participate in the execution. components are participating in the execution. Nodes are execute the components. Nodes are executing the components. Simple. What are components? Components are the things that participate in the execution. Components are the things participating in the execution. Whereas if you take the nodes, nodes are the things that execute the components. Nodes are the things that execute the components. Right. Components represent the physical packaging. Components represent physical packaging of logical elements, whereas nodes represents the physical deployment of a component. Physical deployment of a component will be representing the node. Component and node. Okay. These are the terms and concepts for the components. Right. See. What are these? This is a component. This is one component. Both two are components. POS.exe is a component. Contacts.exe is another component. Node. What is the node? Node is there. The sales node. Sales is a node. In the sales node, is dependent on the POS.exe component and contact.exe component. The node is having the executable components, that is POS.exe and contacts.exe. Example for the node and components. Connections are simple relationships. Connections are the relationships. Nodes can be organized by specifying dependency and association relationship. How do we use nodes? Nodes can be organized by specifying dependency and association relationship. Nodes are organizing for specifying dependency relationship also. You may use or the that is dependency. You may use association relationship also. An association generally represents a physical connection among nodes. Nodes, as we studied, any diagram contain association, no direction there, but association can give a unidirectional path. If you give the direction also. An association generally represents a physical connection among the nodes, such as an Ethernet connection or serial line connection or satellite connection. These connections, for these type of connections in the deployment system, we use association. Use association. Nodes can be organized by specifying dependencies and association relationships. An association is generally represents a physical connection among the nodes, and such Ethernet connections, serial line connections, or satellite connections. And there also you can use associations or the dependency. Those are the connections of a particular dependency system. Right, next. This is one important where we use association in between the different nodes. This node is a server. This node representing a server. This node representing this node represents a console. This node represents the console. Okay. So this node kiosk server, the 10th Ethernet server. RAID farm, RAID, farm, and a server, that is one server. Okay. So deploys admin.exe, config.exe are the deployments available in the console node. Okay. The relation, what is the relation in between these RS-232 relation? Here 10 T Ethernet relation. Okay, here no relationship name, but it is connected. Example, Ethernet for the representation of Ethernet processes, or for the representation of serial line connection, or for the representation of satellite connection, Ethernet connection, we have to use association. Association is a symbol that will have to connect from one source to the destination, or the destination to source, destination. So no direction we give. Association is nothing but a bidirectional flow of a flow of thing in the relationships. Okay. Now this is the kiosk deploys username. This way we have to connect. And next, common modeling techniques. Common modeling techniques for the representation of deployment. Common modeling technique. And the first one, modeling processors and devices. Modeling the processors and devices. Identify the computational elements of your systems. Deployment view and model each as a node. What kind of computational elements are there? You have to observe, identify those computational elements and deploy them in a model for each node. For whatever the computational elements you found, those computational elements has to be represented with the help of the node. If these elements represent generic processors and the devices, then stereotype them as such. What the stereotype representation you may also give for these connections. If they are kind of processors and devices that are part of the vocabulary of your domain, then specify an appropriate stereotype with an icon for each. For each, you may represent an icon with the help of some stereotyped value, stereotyped name, and also iconic representation also may be used while you are designing a computational elements for a particular processors and the devices when you model, right? As with the class modeling, consider the attributes of your operations that might apply to each node. Constitute your the attributes of a particular system or operations you might be give for each node, right? So see this example what we studied in the previous example, right? Here the 10T Ethernet. 10T Ethernet will be of the connection of association. RS-232 connection of association. Our right form is it. All those are nodes. Instead of representing the nodes when we design the modeling of a particular deployment system, and there you have to write the icons. This is one icon of kiosk system. This is one icon of console system, and this is the nice icon of right form system. That iconic representation is also given while designing the computational resources with the processors. Processors are the servers. Processors are the servers. You have to represent the iconic representation with the help of the relation, association, relationship. And the second one is modeling the distribution of components. Modeling the distribution of components. How do we distribute the components of a model? For each significant component in your system, for each significant component in your system, allocate it to a given node. Allocate it to a given node and consider duplicate locations for a components. It's not uncommon for the same kind of component, such as specific executable libraries to reside on multiple nodes simultaneously. Okay, so for this, the render allocation is one of the three ways. Render this allocation for each component in your system. Don't make all the allocation visible, but leave it as part of the back plane of your model. That is each node specification. Using dependency relationship, connect each node with the components and deploy. List the components deployed on a node in an additional component. List in an additional component with a node. Right? So these kind of representations we have to found and see different kind of designing a deployment. In this class we studied about the deployments of particular node, deployments of your node. What is the node, what node has, and what is the node relationships exist. Okay? So in this class, we stop at this particular time. The deployment completed. For further next class, we have to see the deployment diagram. Okay? So with this, we have to stop and we will continue to the next session. Thank you.